Okay, so for the purpose of the class and the recording, I'm Randy Kearns, I'm your instructor, and this is the Community Health Research course. Just to recap a couple of things, if you haven't had a chance to look at what's in Moodle as of yet, although classes technically started this past Friday, our first class is tonight, and then we will meet each Tuesday night at 6 o'clock, either here on Zoom or physically in the classroom. Our first physical classroom attendance right now is scheduled for the 23rd of February, I believe. Let me look to be sure. Yes, that's correct. The 23rd, and we'll be in Kirschman Hall Room 122. Right now, as plans go, and because of the pandemic, obviously, you know, this is kind of a work in progress. But right now, the intent is for us to meet about 6 nights between now and the second week of May, which is when the class ends. Most of the time, obviously, it'll be online. Most of the time, it will be right here on Zoom. But anyway, that's kind of how things are unfolding. And let me also be sure and ask, can you see my screen? And when I say my screen, the landing page on Moodle for this course. Is that what you can see?
Yeah.
Yeah.
Okay, thank you. And I think I've had most of you in a class before, but just a reminder, sometimes when you set up Moodle, not every instructor chooses the same arrangement. The system that I use is something called tiles. So if you select this tile, and then it'll take you to the, again, the ones that you can see. And I've opened up all of the content through the week of March the 1st. Some of the other content isn't visible, but again, I'll try to keep things open several weeks in advance. So let's start from the top. And that is, again, because of the size of the course, we have, I think, 26 students registered in the course right now. As long as we don't top 30, if we get to 31, we would have to cancel all face-to-face delivery, at least based on how much infection continues to go on with COVID-19. But those are the rules that we're dealing with right now. Again, they may change in 4 weeks to 8 weeks, depending on vaccination and some of the other things that could be going on and how we deal with the pandemic. Between now and then, the primary goal, well, even when we meet in class, the primary goal will always to be practice good public health, good health and hygiene, and to keep yourself safe. But I think we can do that and do that effectively and still attend a couple of nights between now and May and do it safely. Again, if we have a class scheduled, and right now the first class that we have scheduled face-to-face will be Tuesday night, February the 23rd. And then our next class will be Tuesday night, March the 9th, and then so on. In the Zoom sessions, again, if we have a class, if the class is face-to-face, the expectation is that you will attend the face-to-face class, and I will not hold a Zoom session the night that we hold a face-to-face class. If there's any updates or any announcements, I'll put them in this section here called the spring course announcements. I will not expect you to log in and constantly check that, but one thing that happens whenever I put an announcement in there, it triggers an email distribution. So you will need to check your email. You'll get an email distribution that tells you what the announcement is. And if you want to look at the landing page for Moodle, you can also look at the announcements that way. Attendance, I had a question about attendance, and I just want to be sure I'm clear on that. Attendance will be counted anytime that we physically have class. That will be the expectation, is that you attend class. If you have an excused absence, there's a small deduction. If you have an unexcused absence, it's a larger deduction. If we're not having class and the only interaction is online and through Zoom, to get credit for attendance, you will need to participate in the online discussion before the week that the class occurs or by the week that the class occurs. If you skip the week or miss it for whatever reason and go back to it later, I'll give you credit for participating in the discussion, but I can't give you credit for the attendance. The syllabus itself, let me go ahead and pull it up. So main things to remember about the syllabus. Again, this is one of those courses where we don't have a textbook, so there's not a required purchase. Our main goal this semester will be to help you develop research skills, to help you understand what good research is. And a part of that will include you participating in a group to conduct at least a basic research project, and you writing something on your own that will be specific to your project. So let me give you an example. Let's say 5 of you choose to look at the use of vaccines, and 5 of you as a group project, you'll develop, hang on just a minute, I've got somebody trying to get into the class, let me let them in. So all 5 of you will develop a set of questions, one set of questions, and you'll have one larger research project that deals with vaccines. And then each of you individually will develop a more specific research topic as it relates to maybe the COVID-19 vaccine, or maybe the measles vaccine, or maybe the flu vaccine. But the general topic is something that all of you in your group will participate in, and then you as an individual will need to pick up on that and do something more specific within that topic. We'll have a lot more time to talk about that later, but that's really the crux of this entire class, is helping you develop good research skills, and a part of that includes how you write that up, and so that you know what good research is by the time you complete this course. Again, no textbooks required. One thing, just as a reminder, and again, most of you have had this experience with me in the past, but if you're going to write something, you will need to use the APA format. If you've taken an English class, a history class, or a religion class, you may have used MLA format. I've not seen other formats used on campus. There are about 29 formats. But the 2 most commonly used, or 3 or 4 most commonly used, the 2 most commonly found, at least at UNO in my experience, is APA and MLA. We will use APA format. So if you're not sure what that means, I will give you some examples, and I will give you some websites that will help you format your paper so that it's consistent with APA format. I will make larger deductions later on in the course if you submit something in MLA format. Again, a part of research is understanding the process, and a part of the process is how you write things a certain way. So attendance, you'll build in incremental periods. You will build parts of your paper along the way, and that way by the end of the semester you will have completed a really large research project, and hopefully it's something that I do know of people who've later taken. I've used a similar approach to this for about the last 7 or 8 years teaching research, And I know people that have taken this and refined it a little bit and changed it a little bit and turned it into their master's thesis later on. But it does help you understand the research process and what you need to do to develop good research and where you can find good, meaningful information to help you build your thesis or help you build your project. We live in an environment today more than ever before where there's a lot of different ways that you can look at something, and there's a lot of different things that pass as the news or research, neither of which may be accurate, and in some cases neither of which may be true. And so it is important for us to identify where are the safe places we can find the facts, and how do we assemble those facts in a way that we have the most complete view of what the story really is. That is good research, and that helps you. The more facts you have, the closer you are to the truth. And the closer you are to the truth, the better you can understand the evolution of science or the evolution of any type of theory and how it works from a hypothesis to a theory to a fact. There will be some quizzes along the way, and it's basically about different types of research. There's some really basic types of research, and for the purpose of this work, we're going to stick with basic types of research. We're not going to get overly involved in what may be too difficult a project. I want it to be meaningful to you, but I also don't want it to wind up being too difficult that you feel like it's not completable. Everybody in your class can complete this. Just knowing some of the people that have completed this project before you, I assure you everybody in this class can complete this. There will be a couple of presentations along the way. Early on, you will need to present what's called your question. The best research starts with a good question. And so in a couple of weeks, you will need to put together a short slide presentation of what your question is. And then later on, near the end of the class, you will come back and revisit that. And by that time, your question may have changed, or your research may have slightly altered, just based on what you found and based on what you originally presumed to build your hypothesis versus where you wound up being. Final exam, you know what I think about a final exam. I just don't feel like that measures. I don't feel like there's a lot of value in it. I realize there are other professors who do, and I certainly have a lot of respect for them. That's not my personal view, and so it's my class, and I'm going to teach it this way. So we do not have a final exam, other than you can use it as a means to boost your final grade. But we'll talk about that later on. Again, if you're within a couple of points of the next letter grade, then I would encourage you to take the final exam. But again, I do things fairly consistently between this and other courses. And I think everybody in this course has spent some time with me in a previous course, so you know how I feel about these things. Academic integrity. We had a faculty meeting this morning, and there was a lot of emphasis on academic integrity. Again, I think by now you've already spent some time working with me using particularly Turnitin, and Turnitin is a web crawl system. If you know a little bit about the technology on the backside of it, it performs a web crawl analysis and compares what you've written to what else is out there. If you copy and paste something, it's going to show up on Turnitin. You know that, I know that. So save yourself the embarrassment of me calling you in and saying, 75% of your paper came from this source, and I can show you where that source was. I've had to do that a couple of times. That's uncomfortable. And I know it's uncomfortable for you. So my encouragement is let's just not put ourselves in that position. But, you know, if that's what happens, and we'll deal with it. The world won't end. If for any reason you're sick, you know, we are dealing with a global pandemic right now. Hopefully we're on the downward slope of what could be kind of that final component of you know, pandemics end when enough people have been vaccinated and they've built antibodies to fight off the disease, or they've been sick and they built antibodies to fight off the disease, or people people get sick and die. And so there's really those three groups. We really want to limit the third group, but it is important for us to build that large group of people who've been vaccinated and have built antibodies. And once we get to that point, I think we'll, you know, I think we'll start to see life return to normal, a lot more so than it is right now. Just between now and then, again, the importance is practicing good public health hygiene. And speaking of which, again, if you had a course that I taught in the fall, I was working, and I'm still working with the Louisiana Department of Health. So there's some time during the daytime that I may not be available. The best time to email me is late at night. I won't answer you late at night. I'm an old guy, so I go to bed early. But I do get up early, and I'll typically answer you the first thing the next morning. So if you have a question, email me at night. I'll answer you the next morning. If you email me during the day, if I've got some time, I'll get an answer to you. But more than likely, it'll be later on in the afternoon when I can get back to you. I don't know how much longer that'll last. Right now, I'm working with, there are 32 nursing homes in the New Orleans area, and I'm working with them to help them get their residents and their employees vaccinated. And we run a robust testing program for surveillance to identify who has COVID and then how to isolate and manage them accordingly. But again, hopefully with a little bit of luck, we'll be past the where we are with the pandemic in the coming weeks or months for sure. With that, let me go to, are there any questions on the syllabus? So if you've taken a class from me before, there are a couple of movies that I like, that some are more fanciful than others, but some more specifically look at research than others. If you have a chance to watch at least one of them, I think it'll give you some insight into the scientific process. And again, it's reasonably entertaining. The theory of everything really gives you some insight into how things work in the scientific process. Good Will Hunting is merely entertainment, but it's well written, and it does. Matt Damon was talking about. I saw an interview of him at the later after when he was talking about writing the movie, and he talked about, you know, he had this idea. He was an undergrad at Harvard at the time, and he dropped out to finish writing the movie. Now he actually went on to do quite well, but it is a good understanding of the scientific process. A Beautiful Mind is actually based loosely on the life of John Nash, who's an economics Nobel Prize winner. It again gives you a lot of insight into the scientific process. It also gives you a little bit of insight into mental health. And Dr. Nash suffered from paranoid schizophrenia. Einstein and Eddington, both of them obviously profound scholars, but it also gives you an idea of how people can collaborate and work together in the scientific process. And then The Immortal Life of Henrietta Lacks really gives you insight into the challenge we have with science at times in terms of who do we tell, what do we tell, and what's open to science, and what should we have permission to use. There's a lot of ethics that underpins, there's a lot of fundamental right and wrong that underpins this story. And I think if you have some time, it would be worth your time to watch at least one of these movies. And so let me go ahead and bring up the introduction presentation. So for tonight, I'm going to go through section 1 of the introduction, and let me stop sharing that, and then let me go to sharing this screen. Okay, and just to be sure, the screen that you can see is the title screen, Introduction to Research. Is that correct? Section 1. Yes?
Yes.
Okay, thank you.
Yes.
Okay, thank you. And so we'll skip the introduction part. We've talked about the syllabus a little bit, keywords. And so here's my challenge when I set this on my screens. My camera is here over this screen, and the screen that I'm projecting this on is here. So if I'm looking away from the camera, I'm not trying to be disrespectful, but I am trying to look at the screen. Let me change this so that I can pull this here. There we go. That'll work. Okay, so data is plural for datum, but we seldom talk about pieces of information in numbers of 1. But if you do, it's datum. The plural of datum is data. Information, we'll talk about big data, how to develop a question, how to develop a hypothesis. The opposite of the hypothesis is a null hypothesis. We'll talk about that. Theory, scientific method, the process of the scientific method, descriptive research, historical research. Those are 2 of the easier approaches to research. Correlational, qualitative, true experimental, quasi-experimental. Those 4 are a little bit more challenging. What blinding is in research, what is a good sample size, what's the difference between a sample, the population, and the census, and then what is statistical significance, and then last but not least, the Institutional Review Board. And again, the whole point to research is looking at a problem and then developing a solution for that problem. But a part of that starts with the language of research. How do we describe the things that we're doing, and what are the words that we're using? And a part of this is also to talk about variables, different types of variables, although I don't think we get into that tonight. I will talk just a little bit about the hypothesis. There are a lot of ways you can state a hypothesis, but the most common, the simple way is to put it in an if-then proposition. Again, you'll find textbooks that will tell you there are a lot of different ways you can state a hypothesis. I would prefer you use if and then, because it helps you think through how you're describing your hypothesis. And the best example that I like to use is, or examples I like to use, if I turn the light switch, then the light will come on. And that's my hypothesis. If I walk into a room, if I turn this light switch, then the light will come on. Well, the way I test my hypothesis is I flip the light switch. And if that switch that I flipped is not connected to the light, then my hypothesis has failed, and I need to go back and look at why my hypothesis failed. More than likely, if the switch is there and the light is there, if I turn this light switch on, then this light will come on. Again, I know that's really simple, but that's what I want you to think about when you're thinking about developing a hypothesis. If I do this, then this will occur. And in terms of our research overview, it is important to understand what research is and isn't, to talk about different methods, what type of experimental designs are there, and what types of methods are best. And we'll also talk a little bit about the difference between applied research and basic research. Again, data, I'm not talking about the guy from Star Trek. Datum is singular, data is plural. And again, I'm an old guy, so sometimes I think that's funny. I realize you probably won't, but anyway. It is important, though, to distinguish the difference between data and information. Data are just facts or figures. Data are numbers. Data are points of collection. But when we take those facts or figures, or when we take those points of collection and we put that in context, in other words, four. So I have 4 pencils. Well, that may be a fact and a figure. The figure is 4. The fact is it's a pencil. The context is I need 4 pencils for 4 people to write with. And that's taking data and applying it in the context of information. And it is important for us to not just know how to count things, but how do we apply that count in the context of using the information. Again, a handful of movies. I would encourage you to watch at least one between now and the next time we meet. I do think they help you understand the scientific process. Some are a little bit more entertaining than others. The Theory of Everything gives you a view of Stephen Hawking before he was confined to a wheelchair, but it does give you some insight into how he thought about the universe and how he thought about things. Again, and the others, A Beautiful Mind is well done. Also features John Nash. The only one there that is not based on true facts is Good Will Hunting. And although it's merely entertaining, it's pretty good entertainment. Yeah, so we're not going to use any of these tools right now, but I do want to introduce you to the fact that there are statistical packages that are out there that by the time you advance your academic career, if you wind up in a master's program or you wind up involved in statistical analysis, it will be important for you to understand at least one of these statistical packages, whether it's data or SAS or at risk or SPSS. I'm only mentioning them because, again, the next step in your research evolution, if you do more than what we're going to do this semester, will probably include one of these statistical packages. The only thing I'm doing right now is introducing it to you, but we will not use one of these for our class. It is important to have access to data. You've got to be able to at least analyze the information. For the purpose of this class, our analysis will stick with just something we can do with a calculator or something we can do with Excel. It will not be complicated, and it will not include one of those statistical packages. And it will be important for us to understand research methods. We have to have a reliable amount of data. It's got to be clean, and we've got to have sufficient data. And let me talk about clean data just a minute. So if I'm looking at a data set that has 50,000 elements in it, there's a very good chance that of those 50,000 elements, there may be 50, 500 that are in error. Somebody miskeyed something. Maybe there was a keystroke error. Maybe there was a card swipe error. But the challenge with reliable data to clean data to sufficient data is an analysis of what you have and then a process of called cleaning the data. And what that really means is trying to identify the outliers. As an example, watching the evening news recently, someone talked about someone getting a water bill for $105,000 for last month. It's pretty safe to say that that's a statistical outlier, and if you allowed that to stay in your data, it would skew your mean and median, and the chances are that's an anomaly and that's probably a mistake. But that also, by removing that, it allows the balance of your data, 1,000 pieces, 10,000 pieces, whatever, to more accurately reflect the population. And we'll talk about that. Big data, and oddly enough, I think we've only touched the tip of the iceberg of what big data really means. There was a time that with analog storage, and whether it was tape or whether it was LP albums, or most books look like this, okay? Most books look like this. You open it up, it's got pages, it's got a front, it's got a back. Is that true anymore? It's actually becoming far less common for most books to look like that. In fact, it's becoming far more common for most books to look like something that came on a flash drive, or something that I can download on my iPad, or something I can download on any tablet. And the point is that allows you to, I literally have several thousand books in my house that look a lot more like this than this. But as we make this evolution to being able to store large amounts of information in very short, small, compact areas, it gives us access to even more information. And I will tell you, the more information you have access to, the more likely you are to collect all of the facts, and the more likely you have all of the facts, the closer you are to the truth, the closer you are to developing that next theory or that next fact. 1 year and 2 months ago, 1 year and 3 months ago, we had no idea what coronavirus, SARS-CoV-2, this particular coronavirus, we had no idea it existed in the human population because it didn't. In October of 2019, it still did not exist in the human population. It had been identified for several years in the bat population. And in fact, there's a number of academic papers that showed the genomic sequencing of the virus in the bat population as was tracked in a lab in Wuhan, China. In fact, the way that we knew this was naturally occurring was the genomic match of the virus today still matches the virus that was found in 2012, 2013, and first identified in bats. But it's through this enormous amount of information and that genomic type sequencing that helps us understand both the composition of the virus and how to develop a vaccine. In fact, some of the people that will tell you that they're reluctant to take the vaccine is because of how fast it was developed. The reality is science is moving really at the speed of light today simply because of how much information we have, how quickly we can process the information. The fact that this particular virus had been studied 5 years ago in the bat population. And to be frank with you, there are thousands of viruses that are naturally occurring in other animals, or particularly birds, that we know the genomic sequence, but it's not made what's called a zoonotic jump, where it's moved from an animal to a human. But if it does, then we have the genomic maps that tell us what that virus looks like and help us develop a vaccine for it. And so the huge advantage to big data is just that. We have this wealth of information. Now the challenge is going to be to sort through all of the information to get down to those things that are going to help us the most. And there's still going to be some trial and error of things that logically make sense, but don't always work out. And I'll give you an example. Hydroxychloroquine early into, so this particular coronavirus is actually known in the scientific world as SARS-CoV-2, SARS-CoV-2, because it's very similar in structure to SARS-CoV-1. SARS coronavirus first appeared in 2003, and a treatment for it was identified in 2005, and the treatment for it happened to be hydroxychloroquine. And so when SARS coronavirus 2 first emerged, the theory was, well, hydroxychloroquine works with SARS coronavirus, maybe it'll work with SARS coronavirus 2. Now, the scientific study was less than encouraging, and so people who are not involved in politics typically abandon hydroxychloroquine and moved on to the next thing. But there was very good basis for why it may have worked, why at least we thought it could work early on. I can't begin to explain why some politicians continued to embrace it later on, but the scientific world moved on because the evidence pointed us in a different direction. And that's why it's important, is to continue to look for the evidence. And wherever the most evidence is likely where our solutions lie. And with big data, with lots of information, we have the ability to make those types of steps. And through the research process, we start out with a good question. From the question, we develop a hypothesis. From the hypothesis, we test it. If we, depending on our testing outcomes, we may develop a theory from it. And theories may take us to facts, but sometimes theories take us to new questions. And so when we talk about the three stages of research, it starts with a good question, it moves to a hypothesis, and if it's good, it will evolve into a theory. It is important to recognize that a lot of research that we do today is based on something that we did last year or 2 years ago or 3 years ago. Again, I mentioned hydroxychloroquine. The research on hydroxychloroquine had been done through SARS coronavirus back in 2005, 2004, after it appeared in a natural setting in 2003. And so a lot of the new research was based on old research, but your research isn't about copying somebody else's work. It's about taking what somebody else did and learning from it, and then what's a better way to do it. So much of what we do today is improving on what somebody else did. Occasionally, you need to abandon what somebody else did and do it a different way. And the best story I've ever heard about that was Henry Ford. Henry Ford talked about, somebody asked him how he came up with the automobile. He said, well, I had to think in a different way. He said, what do you mean? He said, if I interviewed 10 people and I asked them what they wanted, they would all tell me they wanted a faster horse. He said, nobody would have told me they wanted a car. He said, I had to be creative in thinking about a car. And that's what I would encourage you to think about doing. Research is typically about making something better, but sometimes it's including the creativity of thinking what's another way we can do it. So you need to think about research in two lights. Number one, how do we improve what we're doing? Number two, what's an alternative to what we're doing? And so the best research needs to be replicated. It needs to be something so that you can replicate it. In fact, there was someone, and we'll study some of his work later on, who in the late 1990s said that he had found a connection between vaccines and childhood diseases or childhood conditions that develop because of the vaccine, and really stood the scientific world on its ear. Well, the problem was, once he published his research, nobody else could replicate it. And what they realized was he had faked his results. He did an enormous amount of harm to the world of medicine because he left a lot of people questioning vaccines, when the reality is his conclusion was based on faked results. He actually had some ulterior motives to wanting to fake the results. But the whole point in being able to publish your research is to publish it in a way that somebody else can replicate it. It's got to be generalizable. What are ways that we can generalize it? It can't be done in isolation. It has to be tied to theory. It's got to be something that you can do. Typically, it's ongoing. Sometimes it's incremental. And it certainly has to be apolitical. A part of what really was discouraging about the recent presidential election, it is almost got to a point of where if you believed in science, you voted for one person. If you didn't believe in science, you voted for another person. And that should never happen. We should always be at a point where you believe in science, and that allows you to vote for either political party. If you have somebody that doesn't believe in science, I don't know. That's a real challenge. But science helps us understand the world around us. We can figure out what to do with it, but science helps us understand the world around us, and that should not have politics tied to it in any setting. And then how do we look at the scientific method? It is important to think about the standard sequence. And again, the standard sequence starts with developing a question, asking, you've got to create a question. What is your question? If you look ahead over the next couple of weeks, you will see one of the most important things you will have to do for this course is to develop your question. What do you want to research? What is important to you? What is interesting to you? And we'll start with some kind of big buckets. And I'll give you a chance to form your own groups. I'll give you a chance to come up with your own ideas, but I'll give you some basic buckets of questions to start with if you're not sure where to get your start from. Again, vaccines are always a good place to look. Things that occur on campus, whether it's sexual assault, sexual awareness, whether it's drugs on campus, what are things that we can do to create a safe campus environment? And then there are a number of things that we can do to look at the safety features of things that are at the University of New Orleans. There's a lot of public data that's available out there that we can compare. What are things that have happened at UNO to other campuses? I live very close to Loyola University and Tulane University, and they have a different experience. They have a different college experience, and they're also more susceptible to crime than we are at UNO. but a part of that goes back to, again, just the nature of different parts of the city of New Orleans. Again, as far as asking the question, identifying the need, developing the question, all of that will come out of this process where we help develop our focus and help develop our question from that. And then what are important factors for your research? What can we investigate? What's interesting? And sometimes good questions lead to more questions. But when we're formulating the hypothesis, we do want to think in the if-then relationship. If I turn on this light switch, then the light will come on. That's really a way to think about that. Think about what is objective as well. And just understand objective means it's measurable or it's testable. Let me give you an example. If I told you that if I checked my pulse rate and I told you my pulse rate was 76, that's my heart rate, how fast my heart is beating, that's objective, okay? I can measure that, it's quantifiable, I can count that. If I told you that I feel flush or I feel cold or I feel hot, there's a certain subjectivity to that. I'm telling you how I feel. In fact, if you think about people that may be in the same room you're sitting in right now, is there anybody else in the room you're sitting in that may have a different opinion about the temperature of the room? And that's because that part is subjective, how they feel about what's going on. The objective piece is if you can walk over and look at the thermostat and the thermostat tells you it's 68 degrees or 74 degrees, that's measurable, that's objective. The subjectivity to it is how they feel or how they tell you that they feel about certain things. It is important in developing a hypothesis and how we deal with facts to be able to separate the objective from the subjective. And then relevant information. What are things that we can test in terms of the hypothesis? Again, how do we look at the general problem in our study or in our research? And then different types of statistics. The most common type in testing the hypothesis is descriptive statistics. And also inferential statistics. So descriptive statistics are, if I have 5 pencils, I'm counting 5 pencils. So I know that there's 5 and I know that they're pencils. That's a descriptive count. The example that I use, the actual number of women who live in the parish of Orleans. The inferential statistics could be, let's say I collect a sample size and from my sample size, you know, for me to understand the number of women of childbearing age or the number of women who have 2 children or the number of women who have 1 child, I don't have to interview every woman who lives in Orleans Parish. I have to look, though, at a statistically significant sample that I can use to infer from a smaller subset, my sample size, what that applies to the population. Again, we'll go over this some more next week, but just to understand the difference between descriptive and inferential statistics. Descriptive, things I can count, and inferential, what I can infer from a smaller sample to the larger population. Again, we'll talk about that in more detail. Let's see. If we confirm our hypothesis, then we plan new research. If the hypothesis is refuted, then we try to understand what happened. We may go back and state our hypothesis both in a way that we can understand it, and we may state it in a null hypothesis. With the null hypothesis, there's no statistical significance between the 2 samples. the best way to think about it is, if I turn the light switch, then the light comes on. That's my stated hypothesis. The null hypothesis is if I turn the switch, then the light will not come on. There's no relationship between the switch and the light. The null hypothesis basically states the opposite of what your hypothesis is. What else do we want to talk about? So it is important to be able to test your hypothesis, compare against the null hypothesis. Again, the difference between the null and the research hypothesis. We're probably not going to set this up in an equation so that you're using Greek symbols or Roman symbols, but if you see that, that's what that means. And then as we move through our hypothesis to develop a theory, we start to bring pieces together. And so one of the last stories before we wrap up for tonight, Copernicus was really the first astronomer who said, you know, I just don't. Okay, let's go back in time to the 16th century, 1543, the 16th century. Copernicus is thinking about how the Earth moves in relationship to the sun. Much of the world believed that the sun revolved around the Earth. And Copernicus did a number of mathematical equations based on his view of the stars at night and understanding both the rotation of the Earth as he understood it, as well as the relationship of the Earth to the sun. And instead of what was commonly believed to be the sun revolving around the Earth, he believed the Earth was just a sphere that, along with other planets, revolved around the sun. And in fact, his 6 books concerning the revolutions of the heavenly orbs produced this in 1543. And even at that time had identified Mercury and Venus. Terra is Latin for earth, Sol is Latin for sun, but he understood the revolution of how the Earth and other planetary bodies revolved around the sun. He tested his hypothesis and developed this theory. Now, there were a lot of people that saw what he did as sacrilegious. There were, because the church at that time had embraced the notion that the sun revolved around the Earth. And so he was not well thought of. In fact, he was much of his work was better appreciated after his death than while he was still alive. But it's because it was so different, it was so groundbreaking, and it flew in the face of what we believed to be true at the time. But all things being equal, again, the more facts we have, the easier it is for us to come to the conclusion. And whatever that conclusion is what the truth is. No matter what we want it to be, it does reflect a collection of all of the facts. And the whole point to that is just understanding theories can be modified and lead to new questions. You know, actually, if you go back to his look at the evolution around the sun, the real challenge with, although Pluto is not in this, the real challenge with Pluto later on is Pluto has somewhat of an elliptical orbit instead of a more circular orbit. And so part of the challenge in actually Pluto being removed as a planet later on was the reconciliation of trying to decide what spheres exactly orbit the sun in more of a circular fashion, and then what qualifies as a planet. But again, that gives you an idea of how theories can be modified and lead to new questions. And at this point, let's go ahead and bring the end of session 1. And let me ask, do you have any questions? I want to be sure and go to, so for this week, the only thing you need to do is review this information that's in this slide set, because you will see this again, or you'll see questions about this again. Let's go to the tile for next week. So the tile for next week, you'll need to create a ResearchGate account for next week. There will be some things that we'll go over. Here's a list of potential topics. I would like for you to pick one of these potential topics in kind of a global scale, and then for your specific question, you will develop a question within the confines of that topic. Again, if the general topic you pick is vaccines, then you can develop a specific question within vaccines to talk about the measles vaccine, the flu vaccine, and you can talk about the flu vaccine in a small community and Plaquemines Parish. You can talk about the acceptance of the measles vaccine to, when we develop our question, we need to think about where we're going to be able to find data to help us measure our question. But just, again, kind of the big overarching bucket is, if vaccine is what you want to choose, then that's your big overarching question. And you'll work with a group of people who have a similar interest, and then you will specifically develop something within that topic, or illicit drug use, opioids and other drugs, or active shooter awareness, fire disaster preparedness on campus. But those are some general topics that are out there. And if you have something you want to do on your own, just talk to me about it, and we can go from there. And again, next week, there will be a quiz at the end of next week that reflects the content that we cover next week, as well as what I covered tonight. So when you see the quiz for sessions 1 and 2, that reflects a part of what we did tonight. Again, I would encourage you to look ahead to next week, since all we did tonight was just what we did tonight. And it looks like I need to clean up a link for the ResearchGate account. Other than that, that's all I have for tonight. Are there questions?
Yes, sir. I had a question. I mean, it's not really related to what we talked about tonight. It was just involving something my advisor recommended me to do.
Okay.
She told me that rather than getting my master's in healthcare management, I should focus it on maybe do an MBA instead. Do you agree with that, or?
So you can get an MBA with a concentration in healthcare, and I would. I have a master's in administration with a concentration in healthcare.
Okay.
I think it depends on what you want to do. I will tell you, an MBA is a really good general degree that helps you understand business on a global way, and I think an MBA is certainly attractive to a number of people, both in the healthcare world as well as the business world.
Okay.
So it does give you a broader set of options, and MHA helps you more specifically target healthcare. But getting an undergrad in healthcare, I would tell you to strongly consider both, and either I think would work for you, just depending on what you want to do.
Okay, awesome.
Sure.
Thank you.
Sure. Are there other questions? So let me go ahead and wrap this up. What I will tell you is, again, as I've done in the past, when I close this out, it'll start converting to a video file. I'll probably post it to YouTube in the morning. before 10 o'clock, and then connect the link from YouTube back into the Moodle shell. So if there's anything you need to review, you can go back and review it. And certainly if you have a question, please let me know. Just understand there's a general time during the middle of the day that I may not be as available, at least for the next several weeks. Okay.
Okay, thank you.
Okay. I am glad I got to see you all again. Even if we're on Zoom, I do hope that we'll be able to have at least a few classes in person, and we'll do that again, or we'll do that starting on or about February the 23rd. So look for that a little bit more as we get closer to it. But until then, if you don't have anything else, I'll say good night.
So for next week, we're going to be creating a ResearchGate account, because that'll be my first time doing that, actually doing that account.
That's okay. So next week, if you'll look in the shell, or if you'll look in the tile for what are the things we're doing next week, you'll create a ResearchGate account, and I had a video posted of how to do that. And it looks like that video is dead, so I need to go find another one. If nothing else, I'll create one of how to. The whole point is, where are places that we can find good research, and ResearchGate is LinkedIn for nerds, I guess, is a way to put it. But it helps you find good published research.
So also next week we'll be making the PowerPoint. Do you have a specific amount of slides that we have to do for the PowerPoint?
So there's a sample that's there. I think it's 5 or 6 slides, and you'll need to submit it at the end of next week for the 3rd week, because the 3rd week when we meet is when you'll need to do your presentation of what your question's going to be. And that's really what your slide deck, that's what your slides will be, is just presenting your question.
Is our, like, are we supposed to have our question picked by next class?
No, you will need to have your question picked by, I think let me look, by the 21st.
Okay.
Yes. And to be honest, the question that you picked by the 21st, you may wind up tweaking a little bit between then and a couple of weeks later, as you start doing annotated bibliographies and you start finding what research is out there or what research is not out there for what you want to do. And it may help tweak or adjust or slightly alter what you want to do. Is that helpful?
Yes.
Yes.
Okay. Are there other questions? Okay. Well, again, I'm glad I get to see everyone tonight, and I will see you next Tuesday night on Zoom here at 6 o'clock. And until then, have a good night.
Question.
Oh, yes.
That's your office?
No, that's a fake background. That's okay. It's from the medical. Yeah, it's from Star Trek. So anyway, okay. Y'all have a good night.
Bye.
Good night.
Thank you. Bye.
Thank you.
Bye.